Hello everyone, and welcome to a factoring review. We're going to start with the fact that if we had the parentheses in the expression 3 times x plus 5, and if we distributed that 3, we would wind up with 3x plus 15. Factoring is the complete opposite of this, where I'm going to give you the 3x plus 15, and you have to actually tell me what was being multiplied. So the first type of factoring that we're going to do is what we call GCF, which is the greatest common factor, and we think about what number or letter appears in both terms. So the number 3 is something that appears in both terms. So it winds up to be 3 and then x plus 5. So the greatest common factor is the complete opposite of distributing. Let's take a look at a couple more examples. So if I started with the example 5x squared plus 10x, I would think about what the greatest common factor is. When I ask myself what letter or number appears in both terms, they both appear to have a 5 in them. And what I mean by that is 5 times 2 is equal to 10. They also both appear to have at least an x in them. So the greatest common factor is going to be 5x times x plus 2. Now you might be wondering where these numbers come from. If I was to take 5x squared and divide it by 5x, I get x. And if I was to take 10x and divide it by 5x, I would get 2. So both of these numbers wind up in my binomial. As far as GCF goes, there are many different ways to do GCF. So if I was to have a longer expression, like 3x squared plus 12x, I could ask myself what letter or number appears in both terms. And in this case, I could definitely take out a 3, and I would also want to take out an x. Can you think of what would be left in the parentheses? It would be x plus 4. Now the way to confirm that we've done this correctly is to go ahead and distribute the 3x back into the binomial to see what we get. That gives me 3x squared plus 12x. If this matches what I started with, then I know that it's correct. Okay, the next type of factoring is something that looks like this. It's x squared minus 25. Some of you might remember this as the difference of two perfect squares. The difference of two perfect squares. And we automatically make two sets of parentheses. The square root of x squared, which is x, goes in the first spot of the parentheses. And the square root of 25, which is 5, goes in the second set, in the second position of both parentheses. And this is the most important part with the difference of two perfect squares. One of the parentheses has a minus, and the other one has a plus. That will always work for dots, or the difference of two perfect squares. Let's take a look at another example. If I was to have x squared minus 169, I identify this as the difference of two perfect squares because x squared is a perfect square and 169 is a perfect square. So we make two sets of parentheses, and it winds out to be x and x. The square root of 169, which you should already know, is 13. So 13 goes in both sets of parentheses, one with a minus and one with a plus. To check this, I could double distribute or make the rainbow. Some of you remember this from last year. It winds up to be x squared plus 13x minus 13x minus 169. And you should realize that both the positive and negative 13x cross out, and I'm left with x squared minus 169, which is the same as what I started with. The next type of factoring is trinomials, and this is what it looks like. It will have x squared plus 7x plus 12. The reason that it's called a trinomial is because there are three terms. 1, 2, and 3. So you might remember this from last year, but it needs to add or subtract to 7, and it needs to multiply to 12. You have a couple of different choices. when I'm looking at the number 12, I think to myself, 1 times 12, 2 times 6, 3 times 4 all multiply to 12. And the correct one that I want to use is 3 and 4, because 3 plus 4 adds to 7. So I wind up with x, x. The signs of the trinomial become very important. When I have pluses in both, it winds up to be plus and plus. I'm going to put the larger number in the first parentheses and the smaller number in the second. So it winds up to be x plus 4 times x plus 3. The next example, we have something that might look like this. X squared minus 8x plus 12. So again, we want it to add or subtract to negative 8, and we want it to multiply to 12. So if I looked at my factors of 12 again, 1 and 12, 2 and 6, 3 and 4, I would not choose 3 and 4 in this case. This one is bad. And 1 and 12 is also bad, because I'm trying to produce a negative 8. The numbers 6 and 2 would work, provided both signs are in fact negative. Negative 6 and negative 2. So to check this, x times x is x squared, minus 2x minus 6x plus 12 winds up with the original trinomial, x squared minus 8x plus 12. Alright, so it's super important that you are careful with the signs that you wind up putting into your binomials so that the numbers work out correctly. Again, in this case, we want it to add or subtract to be a negative 8 and multiply to be a positive 12. The last type of factoring that you have to be familiar with is actually when the directions say to factor completely. It's in essence two factoring problems in one. Always, 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 you want to factor in the following order: GCF, dots, and then a trinomial. By the way, please make sure you're writing all these notes down. I'm not sure if you're copying them or not, but you should have the notes as well as the examples. Let's take a look at a factor completely example. So it will definitely look something like this. 3x squared minus 75. So first I check to see if there is a GCF. And is there a number or a letter that appears in both terms? Absolutely. I'm going to pull out a 3, and I'm going to be left with x squared minus 25. Then I ask myself, is it dots? And the correct answer is yes. X squared is a perfect square, and so is 25. X minus 5 plus 5. So that is definitely how you factor this, and factor it completely. If I wanted to check for a trinomial, I could, but I would realize that there are no trinomials left, and the correct answer is 3 times x minus 5 times x plus 5. One more example, it may look something like this. 3x squared minus 6x minus 45. I ask myself if there's a GCF, and the correct answer is yes. I'm going to pull out a 3 and be left with x squared minus 2x minus 15. Then I check to see if it's dots. It does not look like the difference of two perfect squares because it has 3 terms. Then I ask myself, is it a trinomial? So I need the numbers to add and subtract to negative 2 and multiply to be negative 15. So if you're not sure of your factors of 15, you might want to write them out. 1 and 15, 3 and 5, and that's it. I must, in this case, use 3 and 5. So I'm going to wind up with the parentheses, 3x, x, and it's going to be minus 5 and plus 2 in this case. If I wanted to check this, I would double distribute this set of parentheses out, and I get x squared plus 2x minus 5x minus minus 15. This is a 3, by the way. Please make sure you change that. And then I wind up with x squared minus 3x minus 15. And when I times it by 3, I wind up back to the original x squared. 3x squared minus 6x minus 45, which is exactly what I started with. So again, the way to factor this, you wind up pulling out the GCF, and then you do a trinomial. Thanks, and I'll see you later.